flight to catch later on, so we've got this earlier stop. So just run through quickly, we have a modular air cooled condenser. It's for a power plant application, so any power plant that uses steam can use this condenser. It's part of the Rankine cycle where you have a steam turbine, you have steam coming off, and you need to turn it back into water at the end. So typically up the top here you have steam coming in, down through these tubes, and then converted, it comes out as water along this blue channel here and back to complete the cycle. Our innovation is the way we do this. So typically speaking, we have a large 10-metre fan in here, and it's blowing air up through these tubes and condensing the liquid back here. So that's the standard ACC or the conventional ACC. And the innovation that we have, or the key thing that you will notice if you're familiar with that type of technology, is that we have a number of fans located right underneath the tubes, rather than this large 10-metre fan. And what this allows us to do is to make some intelligent decisions around how fast these fans should be run, which fans should be run, which side should be run, which side should be turned off. So along with this, we also have a control cabinet in here, and in the control cabinet and around we have sensors to monitor, say, the ambient temperature, the steam pressure up the top, the temperature of the condensate coming out, the wind speed, the wind direction. And we're taking all these variables into account, and we're using this information to create an intelligent decision on what speed these fans should be running at to get the optimum steam condensation for the least power input. This is in contrast to what's there conventionally, because conventionally you just have this 10-metre fan, you turn it on in the morning and it does its job, but there's no intelligence around what speed it should be running, and there's also, say, areas of the heat exchanger that aren't working, whereas in this scenario, because of the proximity of fans, everything's working. Have we one more minute left? Yeah. One more minute, right? Okay. So this starts like with everything on it. This is all the great things about our product over the conventional ACC. So just to list a few of them, we've uniformity of airflow. That writing's a bit small actually. We optimise for the wind, so if the wind is coming from the north, we know it's coming from the north, we will make an intelligent decision on which fans turn on, which fans turn off, and use the power of the wind. We have reduced fan power consumption, so anything that, any power that is used to condense this liquid obviously gets minused off the net power plant output. Lower maintenance cost. Because of proximity to fans, if it's in a dusty environment, which a lot of these will be, the dust can get blown off, because the fans are right underneath the heat exchanger. Reduce noise and vibration due to small fans. We've intelligent control of the fans, so we can do part loading, increase net plant output, and we were also modularising it, so it can be brought straight to site, put up, done. Is that 3 minutes?
Yes.
Good.
You finished? Thank you very much. Are there any questions from the audience to the speaker? No?